So now we have the tools. We know where the audit messages are. We can kind of read them. We know how to augment them if we're having problems. So let's actually go into what those problems are going to be. So in reality, there's 4 kinds of problems that you're going to have. 2 of which you're going to be able to solve on your own pretty easily. The third one's going to take a little bit of extra work. The fourth one is not really something you can solve. So the first one is your labels are incorrect. 99% of the time, if you have an SELinux problem, it's because some label is not correct. Some file is not labeled correctly, or directory or something is not labeled correctly in your system. After that is we do the best we can with the policies that ship with Red Hat or any SELinux operating system. And the best we can do is, given the default configuration for the system, we can give you a policy for it, because we can't tell how you're going to change it later on. So the idea is you've changed the configuration away from what the distro default is, and now we need to update SELinux on that and keep it aware of it. The third one, bugs in policy. So this is either the policy is new and we haven't gotten to everything yet, or notoriously, no one tells the security people when they make changes, right? So let's say all of a sudden someone introduces a new Apache module that does something that has never been done before. And they all of a sudden put it in the distro, and even worse, they enable it by default. You need to tell the SELinux policy this, and no one's going to go over to the SELinux policy maintainers for Fedora and say, hey, I put in this completely breaking Apache module that's not going to work anymore with the default policy. You should go and look at it and actually update your policy. So that's another kind of problem that there will be. And the fourth one, which is there for shock value, Dan Walsh put this one in, is it could legitimately be someone is trying to break into your system. That the denials that you're seeing are not, the program's wasn't updated correctly policy-wise, but someone's actually trying to exploit a service and make it not work and do something it's not supposed to. So let's start looking over labeling problems first. So we're actually going to get some hands-on stuff here. So 2 tools, start messing around with them. SEManage is a multiplex command. If you type SEManage and just hit enter, you're going to see all the different categories of things you could do with it. There'll be fcontext, there'll be login, there'll be port. There's a whole bunch of them. Permissive is another one for per domain permissive modes. And this is going to be your main workhorse program with manipulating SELinux context, manipulating the system store, and fixing problems. Because 99% of the time, if it's a labeling problem, this is going to be how you fix it. Another one is that, for example, files may just be created in the wrong label. For the longest time, we didn't have the ability to differentiate. If we had, so with the cool thing about type transition rules is it allows us to create files with the right label too. So you could say when Apache, running as HTTPT, creates a file in var run, which is labeled var run t, the resulting file gets labeled with the Apache's PID type, which is a really cool thing to do. It allows you to make files with the right domains to start out with. But the problem was, what happened if you had 2 files in the same directory that needed different labels? And the answer to that used to be, you were just shit out of luck. You needed to run the restoreCon command after the fact and make sure that they got restored properly. Now, you can actually create transition rules with a name as the last component. So you could say, if I create 2 files under etc, this one gets labeled this label, this other one gets labeled the other label. So that's a cool new feature, but something that you're not going to see unless you are running, I think, a CentOS 7 system. So let's go into actually seeing some use cases. So this is a real life use case. Who's ever uploaded a tarball to a system in temp and extracted it there? At least 5 people, 6. Let's go with 6. Alternatively, the idea is you could upload it anywhere that's not its final destination and extract it there. So you could also do it to your home directory as well. So this works very well for example, messing up web content. So you extracted, some sort of web app that's going to get put into Apache's doc root or whatever it is, but you extracted it to your home directory. Now, what happens when you create a file in a directory? If there's no type transition rule, it's going to get created with that directory's label. So, for example, if you extract it in temp, it's going to get created with temp t, because that's the temp directory's label. What happens if you then move that into Apache's home directory? Do you think it's going to fix up the labels for you? No, because small little bit of Unix internals here. Move is not an inode operation in Unix. When you move a file, it doesn't do anything to the file itself at all. The file remains completely untouched. The only things that are touched in a move command are the inode of the directory that it's moving from and the inode of the directory it's moving to. So assuming you're not copying across file system boundaries. So the idea here is that because the security label sits with the inode, it doesn't know to update itself. So you have to go in and you actually need to restore the labels on that. So let's pop open the VM for a bit, and we're going to just let's try just make a file called, you can make an index.html in your home directory and see what it's labeled. So let's pop open a. So I'm going to stop being root for a second. Yeah. So if we look in our home directory, we're going to see everything we have is labeled user home t. So if we echo hello world from SEdemo home directory into index.html, the resulting file is still that user home t. So let's look over at, let me look at my doc root path for that first. That's the HTTP. It's a confd. As you can tell, I'm not really there it is. As you can tell, I'm not really a sysadmin. What did I say that one was called? Labels. Labels. So the document root for that's var www.html. All right. So if I were to copy from my index.html into var www.html, oh, sorry. Yep. Also, as a bit of advice, if you ever buy a Lenovo, do not buy one with a number pad on the side, because it makes it so much harder to type. All right, so oh, that's another problem. Yeah, I messed up the move index.html index.html. There. All right. Of course. Let's try that again. Copy index.html to var www.html. Now, this worked. The question is, why did this work? Because when you copy the file, what you're doing is you're actually creating a new copy of the file in the new location. So we have the right security context there for the file because it was a copy, and we inherited the label of our parent directory. Yes, it will, because moving across file system boundaries is actually a copy. It's not a move. But if we move index.html to var www.html instead, overwrite it, let's check it again, we're going to see that the label's now wrong. Interesting. What's this? Do an ls-z on var www and see what is the label on HTML? What system are you using? CentOS or? Yeah. So if you didn't move, it's good. So there is a flag to copy that says preserve all the attributes of this file. And if you give that flag to copy, it will preserve the SELinux context as well. So there is a way to actually have that not work with copy as well. But, all right, so if you're running the VM I gave you, or you put the etc host and the Apache config in the right locations, you should be able to go to what do they call that example? examplelabels.org. Or is it com? Yeah, examplelabels.com. Examplelabels.com. Okay. Yep, there it is. Because the label was wrong, you're going to see that's the SE troubleshoot applet that just popped up that he was talking about, which makes things a lot easier for people. And all right, so let's look at the details for this one. Actually, details is not what I want. I want to click troubleshoot instead. But it gives you a nice little breakdown for it. It says, the Apache process tried to read a file called index.html. Because I didn't actually put that audit rule in, it only gave me the file name at the end. It didn't give me the full path. And this is kind of a what you see is what you get kind of approach. You could, assuming you're running this as root, you can click any of these buttons, and it will apply the change for you. So, so all these are actually completely valid things, but in reality, oddly, this is not giving me a completely valid answer for it. In reality, the answer is that we had incorrectly labeled content. Because of the source label we chose, because of that user home T label, and the fact that there are times where you want to allow that access, this didn't give me the right one. So let's go back to that terminal. And if you want to restore the label of a file, so something that's really cool, there's two tools we're going to look at right now. First is the match path con tool. This says, given a path, what does the SELinux policy believe the label should be? So you can just try running match path con on a bunch of different paths and see what it comes up as. But most specifically, run it on the path of this file. Run it on var www.html index.html and see what it believes the path for that should be. That's probably a little small for you guys to see. Let me see if I can. What is it? Control plus plus. All right, so Control Shift plus. So match path con says that instead of being labeled, where was it? That user home T, it really should be labeled HTTPD syscontent T. So now there's a tool that you can do to fix this. So just like we have chown, chgroup, chmod to change attributes of a file, there's also chcon, which allows you to change the security context. And I could do this with chcon -t for type, HTTPD syscontent T, and then var www HTML index. I could do that. That's completely reasonable. However, let's say I have an entire directory that's messed up, and I don't want to do this by hand because that's just a pain. I could use the restorecon utility, and this will go through, and because I did this recursively, it will do that step of doing internally. It does the query to the policy store and say, what should this file be labeled? Okay, is it that label? If not, change it. HTML. I'm going to do recursive on HTML at this point. And you come up with this nice little line, because I did 2 V's for the verbose mode. We're restoring the context, we're resetting it on that file, and we're moving from this context to that context. So let's say you have an entirely messed up directory with like 50 or 60 files that are messed up. It'll create a line for each one of those, tell you what it was originally and what it moved to. So you have some idea of what's going on. I think so. Match path con. Yeah, if do not display paths, do not do trans. I thought there was like a no op option for this. I think what you need to do is you need to do the -V to verify that they're okay, and if it doesn't verify, it'll spit that out. It won't actually change it. Oh, sorry, that's match path con. Sorry, I need restorecon. Yeah, -N. Don't change any file labels. So it'll still spit out what changed, what should change, but it won't actually change it. So. No. What that's based on is when we get to writing policy, you're going to see there's 3 different files for an SELinux policy file. There's a .te, which is your type enforcement rules. Your .if, which is your interfaces, which other applications use to access your internal types, because you don't want to have to know that about this syscontent T type if you're writing policy. You just want to know, I want access to Apache's system content. And so you use an interface for that. And the third file is what's called a file context file. And it's the mappings that say, this path should be mapped this way. And that's the basis of the semanage fcontext command. So this, did I not do that right? Semanage. Oh, it'd help if I actually spelled it right. C-O-N-T-E-X-T. You'll see so there's usually A for add, D for delete, L for list for every single one of the semanage commands. This is, according to the system, what it believes the mappings of files to be. So for example, bin su, if you go across there, you're going to see that it's a regular file and it should be labeled su exec t. And when we write the policy for our little F transfer daemon, we'll, assuming we get to that, we'll write these lines in the policy and we'll be able to make the F context statements. So this is what it's using. And if you want to look in a policy directory, so if we do etc SELinux. So under etc SELinux, you're going to see that there's a directory for each policy name. So in this case, we're running the targeted policy context, and there's all the file context type files. Particularly under files are the actual file contexts. And this is the actual file that the policy toolchain uses when it makes the policy. And actually, to tell you the truth, these don't actually get put in the kernel at all. So these are completely handled by user space. So these are the actual mappings. And we'll see rules similar to this written in our policy file later on. But this is the store of how things like matchpathcon and restorecon know what to label a file. It goes through this. In reality, what it does is it has I believe it has a binary pre-computed regular expression file that it uses, and it just loads that up and uses that directly as opposed to chunking through all this stuff. For a while it didn't. For a while it actually matched against this stuff by hand. But so, has everyone done this part of the exercise? Or at least everyone who wants to do it? I'm not going to force everyone to do everything. But. All right, so if we reload, we fix the security label. Now we can actually get access to that content. Is everyone happy with this explanation? Or so let's do the next one, because there's going to be like 4 or 5 total in this area. So move instead of copy, move instead of copy. That's the solution for move instead of copy. All right, so now this is where things get hairy. This is what I called non-default configuration. And this could be many things. This could be you want to change the port that Apache listens on. As you know, I've apparently spent a lot of time making this for Apache because it's really the only thing I'm saying at this point. But the options are, I'm serving out of a non-default directory. So basically, Apache SELinux expects me to serve content out of certain paths. I'm changing that path. For example, let's say I get I'm looking on the internet and this web app says that it wants me to extract it to opt instead of var www instead. So we'll figure out how to tell, obviously we can easily tell Apache to look in opt. We need to tell SELinux that opt is going to behave the same way as var in this case. Another option is, and this is what's called policy booleans. For example, you don't necessarily want your web server always able to connect to the Unix domain socket for MySQL, right? If you're not using MySQL for any of your web apps, there's no reason for your web server to connect to the MySQL domain socket. So because of that, we have what's called conditional policy and these booleans that we can turn on and off to say this functionality is sometimes used, but it's not safe to have on by default. So what we're going to do is we're going to set it in its own small component, and we can turn it on and off as needed. And the last one is we're going to share stuff on, we're going to change the port for Apache from 80 to 10.321 instead. So let's get through and work through all these. So first use case, we're going to actually serve out of opt www instead of var www. So if you guys want to start working on how to do that, I don't know if you have Apache configuration skills or whatever, but if you're using my VM, it's already configured for you in a domain. You just need to copy the stuff over from var www to opt www. So let's start by doing that. And then once you get there, so this is a little bit contrived because we're using copy. Oh no, it'll fail because we're using copy and we're not using move. So yeah, just copy recursively everything from var www to opt www. If at any time you get confused by this, in the scripts directory, in the materials that I provided you, there is solutions for all this. There's the step-by-step, what I did in my talk last year to actually accomplish all these tasks. So you can see everything that's going on. And it has some sub-steps where it shows you, look at the context of the file after you've moved it. So for example, now that we've copied, let's look at the context of, recursively. So do an ls-RZ on opt www. And just take a look at the context and see what they are. So let me do the same. Copy. var www. I'm just going to copy that to opt. And we're going to do ls-z opt www. Probably should do the -r as well. Pipe less. So, as you can see, these are completely wrong. This is all user T. And if we actually went and looked through var www, we'd see that there were specific labels on specific files that matched their purpose. So, for scripts, there's like an HTTPD executable script T, or I forget what the exact type is. But you'd see types based on the content that was in the directory. In this, it's all completely wrong. So the way to fix this, so in the first thing that I showed you, there was a proper mapping in the file context, but we just didn't have the right file because we moved it incorrectly. There is no proper mapping here for the files. We can match pathcon or restorecon all we want, and it's never going to fix the problem because according to SELinux, this is the right label for this location. However, it's not the right label for the purpose that we're intending the location to have. It's not the right label for serving web content out of. So back in the day, you used to have to do this by hand. You'd have to go and create file context entries for every single file that was special under that location. Now we have a special feature in SEManage called equivalencies. So this came about because one of the guys I was working with, Eamon, worked on the SELinux extensions for the X server. So there is an equivalent of XELinux called XACE in the X server with an SELinux module that does this for the X server components. He would install his own copy of the X server. Well, there's thousands and thousands of files in a specialized tree underneath the X server's install directory. So he used to have a script that would actually make file context entries for that entire tree by hand, which was a nightmare. So what we did is we went in and we said, well, in reality, these 2 points in the file system are exactly the same from here on down, right? So if we move var www to opt www, they're exactly the same from that www folder down. There is no difference in there. Semantically, we want the labels to be exactly the same. They have the same exact purposes. So we do this with SEManage. We want to add, which is what the -a is. We're going to add a new, actually, first we need to say what kind of rule first. fcontext. We want to add a new rule. Yeah. Txt. Thank you. Now, this is the special one here, because you can do an fcontext without this, and you just add that specific rule. What we're going to do is E for equivalence. Actually, and we're also going to give me a second to check my script, because I can never remember if it's source then target or target then source. I think that's scripts. Example, non-default directory, and it should be Yeah, it's the source. Then it's the old directory, so the original, and then the one that we want to make the equivalent. So in this case, it's going to be var www, which is our source, and opt www. So what SEManage does is it modifies that directory I showed you, which is the policy store. Then it rebuilds the policy into its big policy module, and then installs it into the kernel when necessary. So sometimes it's slow running, sometimes it's fast running. It all depends on the actual operation you're performing. So now we can restore con again, VVR. Let's do VVR, and we'll do N to show opt W that it's not going to change it. And it's saying that all these were wrong, and we're going to have to reset them. So let's go back and remove the N. That's actually resetting them now. So if we go through and we look at these labels, they're going to be correct this time. Does anyone want time to do that on their own systems? Or should I keep chugging along? Because I think supposedly we're due for is it 11:30 we're due for a break? What? 10:30. So we have 7 more minutes, so yeah?
With what you did, does that provide the context configuration file? Or?
Yeah, so those so under that file context, a file that we looked at earlier, you're going to see a new entry in there. Actually, you might not see it in there. You might see a new file called filecontext.local created instead. And it'll put it in the local modifications. Because with SEManage, you could do, so let's say you had a development system, so you're not in production yet. You're doing all these changes on the development system to get it set up, and you want to know what you did. You can actually dump the entire SEManage or fcontext changes that you did locally to a file to export into another machine as well. And there's a flag to SEManage that you can specify saying, give me only the local changes that I made. And you can dump those out and then restore them to another machine. So that's one way of doing it. Ideally, if you had some sort of, what is Puppet and Chef called? What kind of tool? Configuration management tool. You'd actually make these part of your configuration management, because Puppet has an SELinux module that you can do and change these things from. So now, just for the sake of it, I missed the part where I actually create a file in opt www called index.html. Opt. HTML. And now if we go to, let's go back to there real quick. What did I say that the, too far. Bugs and policy, what is that supposed to be? Example opt.com. It's allowing access to it. Now, if we didn't do that restore con in the fcontext command, it would have thrown us an ABC denial like last time, saying Apache's trying to access content that it doesn't have access to. So, and likewise, you can always remove. Let's say you decided you wanted to remove this change later on. You can do SEManage fcontext -d with the location you want to remove, and it would remove that equivalence mapping. So, A for adding, D for deleting, L for listing. And actually, if we do SEManage fcontext -L and look at the very bottom, you're going to see local file context equivalents that we set up. So these are all the local ones that we set up in there. So if we had a whole bunch of them, there'd be more than just the opt to var mapping there. It's SEManage fcontext -L for listing. Yeah, L will list the state. For example, we're going to get to SEManage port -L. Oop, no, not what I was looking for. And that'll show all the port mappings and stuff like that too. So if we just do SEManage with nothing in there, we'll see that login, user, port, interface, module, node, fcontext, boolean, permissive, and don't audit are all the the things that SE Manage can take. So I didn't know about the don't audit one. That's actually, I guess, a recent addition. I'm guessing that's the equivalent of doing that SE module -db and the -b that I showed you earlier for moving the don't audit rules. It seems you could do that through SE Manage instead, which is useful. All right, so it's almost 10:30, which means it's 3 minutes to 10:30, which means you guys are supposed to get a half-an-hour break. I will be here if you have any questions, if you want to work through any of the labs, spend some extra time with them. But in theory, there's supposed to be a break of some sort. So, did the non-default locations, did invalid labels. Let's move on to the next lab. Web content and user home directories. Now, when we saw the SE alert window earlier and it said that you could change Booleans to fix the problem and it wasn't giving us the right answer, the reason for that is because there is a valid use case for sharing content out of a user's home directory. So that's why it got a little confused. So who's ever gone to a URL that had tilde some username in it? So you're either not paying attention or you're deciding to just be quiet, because everyone in this room should have probably at some point. That's sharing out of a directory so technically that's not necessarily sharing out of a directory in the user's home directory. By default, it does. So if you look at the user mod Apache module, by default, it's going to serve out of a folder called public_HTML out of your home directory. Now, you could change this that you have per user folders under some other location, but that's where it is by default. So if we try this example, so if we go back to our home directory, we make a directory called public_HTML. We echo hello from SE Demo's home directory, except I think that single quote might mess everything up. Let's escape it just for the hell of it. Into public_HTML, index.html, cat public_HTML, index.html. All right, probably didn't mess it up at all. Now, the important thing is to make sure we have our permissions right on the public_HTML directory, which we do, because we gave other the ability to read and execute it. So we're actually going to pass our DAC check first, because the worst thing to happen is blame SELinux when it's not SELinux's fault. There'll be plenty of opportunities for blaming it. We don't need to make some up. So now, if we start up the browser, .example, was it user home is what I called it, .com. Oh, that's just fun. Do I have this Boolean on? Unified off. Enable home directories off. Why is it? Oh, all right. So this is actually a bad example because they added something recently that fixed this. Now you know how you have the restoreCon tool and it'll restore context for you? Well, there's also a daemon called the restoreCon daemon that will create files in the right context for you when you will relabel files into the right context for you. And there happens to be a mapping for public_HTML in the user's home directory for this. So even though I didn't recreate public_HTML properly, it did it for me. And because of that, the file created under it was incorrectly correctly labeled as well. So what we're going to do is we're going to make this example a little contrived, and we're going to break it intentionally. So we're going to use chicon -r t. We're going to make user home t, and we're going to do public_HTML. We're going to make sure public_HTML is actually broken at this point. Yep, user home t, user home t. So this should be the wrong label now, because it didn't fix it for me. So if I hit refresh here, it should error out. Except it's not actually doing that. Don't you hate when demos fail after they've worked for a long time? What did I... That's so weird. Oh. I love how I told you that I needed to do something and I never actually did it. There. Because I was still reading out of the doc root for the thing. I wasn't reading actually from my user home directory at this point. So yes, so it's actually broken now. And if we pop open SE alert, if it doesn't want to pop open for us, we should get another alert, which looks a lot like the last one we got, saying that if you want to allow it to read user home content, you can. Yep, there it is. Just popped up. Show. Yeah, sorry about that. So here's our fourth alert. We can troubleshoot it. Now, at this point, these are actually completely valid answers because we really do want to share home directory content out of the user's home directory. And there are booleans for this. There's the HTTPD enable home directory. So let's actually, real quick, we're going to introduce two new tools here. You could also set and get booleans through the semanage command, but we have specific tools for it. We have get sebool. We want to show all of them, which is the -a. We'll pipe it. We'll just grep for HTTPD, HTTP at this point. So these are all the booleans that pertain to Apache. And in reality, we'll discuss this with policy in a little bit. There's ways to write policy for a generic class of applications. So in this case, the Apache policy is not just for Apache. It's for any other web server that also runs on the box. So in this case, what we really care about are the booleans that have to do with sharing content out of a user home directory. So if we look in here, we look down, can network connect cobbler, can network connect to the database, we don't care about those. Enable CGI, we have that on, I don't know why. Enable FTP server. Enable home dirs, that one seems important. So that's going to allow us to actually get into the home directories. And I believe we can actually man get se bool. We should be able to see descriptions for this. Se manage bool. Is it bool or boolean? I think it's this. Oh. I hate that. That's protected under root passwords. Se manage boolean -l. So this should show us the booleans with descriptions, I believe. Yeah, awesome. So let's grep this for HTTP and see what comes up. Grep. So this should show us all the booleans that have to do with Apache and the descriptions for them. So enable home dirs here, allow Apache to read home directory. So even if we allowed them to share user content, we have a specific boolean for reading the home directory as well. So we need to turn that one on. And what else do we need to turn on? I believe it was use user content or something like that. Yeah. Oh, is it? Where? Read user content. So those are the two booleans we care about. So let's just go back to the easier to read one real quick. No, not that one. Although I do need to be root for this. So get se bool, grep HTTP. So the two we need are the home dirs, enable home dirs, and the use read user content, right? So we do set se bool this time. Now, let's just look into the ls SELinux booleans directory. So this is the SELinux file system. This is what it communicates with. And if you notice, each one of these boolean files is a boolean. This is the kernel interface for that boolean. And we could echo 1 or 0 to these booleans. We do have to echo something to a commit file as well, but that's not the interface you're going to use. So behind the scenes, these files are what gets tweaked by get and set se bool or se manage booleans. Now, it's possible to change these for the running system, but not have them persist through a reboot. So because of that, there is, to set se bool, let's do that real quick. you have to specify the -P option. And what this says is we want this change to be persisted across reboots. We don't want it to be just this one time, and when it reboots, it goes away. Because this has to be stored somewhere so that it actually happens every time. So we want HTTPD, enable, homeders, 1. I think it's possible to do multiple booleans at a time. I just don't remember the syntax for it, so I'm going to do it the slow way. So this is going to turn on the enable homeders boolean. And the reason it's slow is because it's actually making changes to that etc SELinux targeted policy directory, so that the next time it boots up and loads the policy up, it knows that this is supposed to be either on or off, depending on what we're setting it here. If I didn't do it with the -P, it would be much quicker, because it's just modify that file in SELinux booleans, and then do the commit for it. But without that, without the permanency, then every time we'd have to redo it. Because it's actually rebuilding the policy store right now and reloading the policy. So that SELinux booleans directory, all those files, are essentially user space representations of the kernel data structures backing those. So by modifying those and committing it from that interface, it just changes what's in the kernel. It doesn't change our policy store on disk. That is what the system loads from the next time it reboots. The -B is actually modifying the policy store on disk, rebuilding the policy, relinking all the modules in, handing it back over to the kernel. So yes and no. The final object that gets put into the kernel is a one monolithic binary of everything put together. The policy itself is modular, and those modules get linked at kind of a compile time into the binary that gets put in the kernel. Yeah. Yeah. So you don't have to, when you load everything into the kernel, you don't have to do linking. It's also to minimize the amount of dangerous code in the kernel. You don't want to do language parsing and linking of binary modules within the kernel itself. You want to put that all in a safer user space place and then load up that final blob afterwards. And then just do sanity checking on the data you get in the kernel, as opposed to actually doing the number crunching and the hard work in there. And the last one was read user content. So because I don't particularly care whether or not this happens at reboot, see, that was instantaneous because we weren't persisting it. The only thing we did is we echoed a number to that file system interface. We echoed another number to the commit interface in there saying, commit the policy changes, the Boolean changes that are sitting there currently, and it was done. So now, if we go back to here, we should see it actually working now. Or I could be wrong again. Let me check my script real quick. There might be a third one that I need. Example. Oh, Booleans, that's what I need. Example Booleans. Was there a third one that I'm supposed to have? Yeah, I also need to vim that, not cd it. That's supposed to be working. Why isn't it working now? There is a restore con in there. All right, so that's right. User content T. All right, public HTML. Oh, that's why. I turned something off. Set SE bool HTTP unified 1. That should allow it now. Or it's just not actually working. And the whole purpose of having all these scripts was that they were tested to work. All right, forbidden. Why do I have a feeling that this is because something's not given the right permissions? Public HTML, SE demo. I don't know. Let's see if that solves it. Doesn't seem to be solving it, which means I've done something else wrong. Yeah. So something else in here is not quite right. Let me check real quick. What did I change that? Oh, that's it. Anyone see what the problem is? Yeah, there it is. Yeah, well, yeah, set and force 1. Otherwise the demo doesn't work. All right, so see, even I was too eager to blame SELinux. But, all right, so anyone have any questions on that demo, except for how horribly it went?
When I did the set tool, you were saying that it's reprocessed.
Yeah, so if you do -P to set it permanently, it'll reprocess the policy store and reload the policy. If you just do it without the -P, it will set it like that really quickly, but it will not survive a reboot. When you reboot, there will be... Yeah, it's that Etsy SELinux targeted, because we're running with the targeted policy. It's in there. And as a matter of fact, I have a slide that we're actually going to look at what the directories in there mean. So once we get through these... Yeah. So what you normally do is you have two options. One, Puppet has management stuff for SELinux. So if you're doing Puppet, you can do that. Another one is if you have these changes that you want to make and you made them through SE Manage, you could dump the local changes for everything from SE Manage. It gives you a file, which is basically a transaction file, which will run everything at once in one transaction in SE Manage. And what you do is you load that file into the machine. So you don't copy and paste these files over. What you do is you kind of just dump everything with SE Manage from your local changes and then re-import them using SE Manage. Yeah, like I was saying earlier, from the management perspective, we have some work to do. Management perspective and I say log analysis are two areas where any help in that area is very welcome. I'm assuming with the rewrite of all the SE tools that they're hoping to make that work a little bit better. But I haven't had a chance to look over SE Tools 4 yet. I just know the version 3 stuff that we're working with here. All right, so now the last one, and this one requires you to get your hands a little bit dirty in the Apache config, is who here runs services on non-default ports? More than half the room. So basically, like I said, every object in an SELinux-enabled system has a label on it, right? And ports are no exception. So your ports have labels too. And what's really cool is this allows you to bind a port to a specific service. So for example, if you only have rules that say Apache, the HTTPD_T process can bind to an HTTPD_port_T label, Apache is the only service on that entire box that's going to be able to use a port labeled that. And by default, because the policy has it that way, port 80 and 8080 and all the cache and proxy ports are labeled with that label. So you can confine binding to specific port numbers to specific programs, which is kind of fun. So let's go back to the, so we're done with that one. So Apache on a non-standard port. So we're going to change Apache's port to 10.3.21. If you don't know how to do this, I'll just do it on screen real quick. Vim, etc, httpd conf, httpd.conf. So in here, so there's a lot of instances of 80 in here. What we're actually going to do is we're going to just select the whole file, replace 80 with 10.3.21, replace it globally, except I'm not running as the right user, so I can't actually do that. CSE demo, etc httpd. httpd.conf. Yeah. Now we want to do source 80 10.3.21. Oh, 10.3.21, because that's a free port. Now, something I learned recently when reviewing that book that I didn't know, which is surprising considering I worked on this for so long, if the base policy defines a port mapping, so a mapping of a security label to a port, if it's in that base policy, it cannot be overridden with SEManage. You cannot change the port labeling for port 80 because the base policy defines what port 80 is. So if you need to change to another port, you need to make sure you change to a port that doesn't already have a mapping to it, because you can't modify the existing mapping if it exists. So I don't believe so. I'm pretty sure it doesn't. The only things that can't be overridden from a policy module are never allow rules, which we'll go over in a bit, which are policy language constraints. So basically, this is you saying in the linking phase, this rule must never exist in a policy because of this reason. That can't be overridden. And I believe the labeling for file system types, like saying that this file system supports XADDR-based labeling as opposed to process origin labeling and stuff like that. But that's pretty in-depth internal stuff. That stuff, you'd never need to do that unless you were introducing SELinux support on a new file system. So that's very much internals kind of questions. I don't know. I asked that question when preparing this talk, and no one gave me an answer back. I don't think there's anything philosophically against it. I think it might just be a technical limitation of the tool chain at the moment.
So what ports are quoted? Is it everything in SE services?
See, this is where the management thing kind of falls on its face again. So it's not very easy to find out what ports are in use. So we have SEManage port -L, and we're going to look through this. So to say, is port 10.3.2.1 bound to anything security label-wise? To say that is really hard. The only thing you can do, you can't do that with the current tool chain very easily. With the SE policy binary that's in the version 4 of the tool chain, you can do that pretty easily. You can do SE policy space port -P 80, and it will tell you anything that has a label for port 80. But with this, the best thing we get is here's the port on the left, and there's the port number it has. So I could try and search for 10.3.2.1 and not find anything. But that doesn't guarantee me, because if you see for Amanda port T, the UDP one there's a port range there. So if that 10.3.2.1 is covered in that port range, there's no way for me to know that. You might be able to do that with SE search. SE search might allow you to query the policy itself to do that, but it's not very easy to find an unassigned port. But if you do find one, you can change the port mapping on it. So if let's go back to, yeah. Oh, I didn't realize I still had that open. All right, so let's become root for a second. So if we do service HTTP restart, it should stop HTTPD, and this should fail. And why did it fail? It said Apache couldn't bind to port 10.3.2.1. So let's see what SELinux says. Why did we prevent Apache from binding to port 3.2.1? And basically, it's just saying that Apache tried to bind on a TCP socket, with a TCP socket that it didn't have access to. And it gives you a couple options of what you can do. If you want to allow it to bind on port 321, and this is going to be our actual answer here, we want to set up an SEManage port assignment for it. So we're going to do this by going over. We're going to do SEManage port. Remember, -A adds an entry in. And we want the port type, which in this case should be HTTPD port T. We could find that out by looking in where is it? My root here, yeah. SEManage port -L. Grep HTTP. Pipe the less. Should only be one line. Unless I did that wrong. Yeah. So HTTP port T, so that's the normal port for Apache. We'll notice 80, 81, 443 for SSL is bound to it, 8008, and all the normal Apache ports are bound to it. So we want to create a mapping for that. Is it only HTTP? Yeah, there's no D in there. Let's go back over to our alert window real quick, if I could find where my mouse went. And what was it? It was the protocol, TCP. So this is what I was saying earlier, because if this was a UDP port, we'd have to specify -P UDP instead. And 10.321. Once again, because this is actually modifying the policy store, it takes a while to do it, which is why if you're doing large-scale management of SELinux systems, you have to look in the man page. I don't know the exact syntax for it, but you can make a script that starts one transaction, does all these modifications, and then finally commits it at the end. So you don't have to wait the long time for 15 different port assignments. You could open the transaction, do your 15 port assignments, then close the transaction, commit it to the policy store, and that will run much quicker. So if we go back to SEManage port -L grep HTTP, we're going to notice now that 10.321 has been added to the ports. So now that port has that security label bound to it. It has that type bound to it. So if we do service, HTTPD start, that's fine. It just couldn't get a domain name for localhost. And if we come back here, open up our window, and we do HTTP example port.com 10.321, we should have access to it. So that's the basics of non-default configurations, port management, and file context management. Now, that should get you pretty much your day-to-day poking around solving problems. However, with all this unified stack development and DevOps being a very big push now, as a sysadmin, you're supposed to actually be involved with your developer's development as well. And as they're saying, I'm making this application for deployment in production, you're going to be responsible for managing the SELinux policy for it, because there's no way they're going to actually write policy for their own applications. Because if we could get developers to do that, my life would be a lot easier. So now we're going to go over some policy language basics and actually try and write a small policy for that ftransferd program that I gave you guys. Now, do you want me to tell you what the vulnerability is in it, or do you want to find it on your own? Find it? All right, so we'll wait for that.